In the last video we talked about finding the quadratic equation that went through 3 points. And you might be asking, is there ever an instance where I can find the quadratic giving only 2 points? And the answer is yes, but only if 1 point is the vertex. Okay? Otherwise you always need 3 points. Okay? So here we go. Give you an example. I'm going to tell you that the vertex of a parabola is at 114, and then a point on the parabola, another point, is 2, 10. Okay? And we're going to find the equation. That's our job. Okay, so here's what we do. If we know this is the vertex, we can write y equals a x minus 1 squared plus 14, right? Because the vertex form comes from the vertex of the parabola, and 114 translates to this. So now all we need to do, we're so close to the answer, is to find this. And the way we find a is we plug this value in for x and y. All right, so I'm going to rewrite this. I'm going to put 10 in for y, a stays a. I'm going to put 2 in for x, and then solve for a. All right, so I get 10 equals 2 minus 1 is 1 squared, so 1a plus 14, a equals -4. So the vertex form of my parabola is y equals -4, x minus 1 squared plus 14. And here's something we haven't done that we should probably do a couple of times, because you'll be asked to do this, is go from vertex form, change to standard form. Okay? And that just involves multiplying x minus 1, applying the square to it, and cleaning it up. So what we're going to do is, some people call that double distributive property, we call it FOIL in class. So here we go, y equals -4, and then I get x squared minus 2x plus 1. Don't forget the parentheses so that you hit each of them with a -4. So I get y equals -4 x squared minus 8x minus 4 plus 14. So final answer, this quadratic in standard form is y equals -4x squared minus 8x plus 10. Okay, and that's the answer. All right, so what we're going to do now is just do a recap on the forms of a parabola, forms of a quadratic equation that we're familiar with. There are 3, we've really only looked at 2. So the first one is the standard form. And what that's good for is telling you the direction of opening and the y-intercept. Ooh, I wrote y. I said y and I wrote y. That's not good. Bx plus c. So remember, a tells us the direction of opening and c is the y-intercept. The vertex form is y equals a x minus h parentheses squared plus k, where the vertex is hk, right? That's what that's good for. And then there's a third form, and it's called the factored form. And the factored form looks like this. Y equals a again, and then we have the quadratic factored, all right? And we know that whatever the x-intercepts are, and we're going to call them R1 and R2, we always put whatever the x-intercepts are, the binomial has the opposite sign, so x minus r1, x minus r2. So you might be wondering, if you know the 2 x-intercepts, is that enough to find the equation of the quadratic? And so for instance, if I know that a quadratic has x-intercepts of 4, 0, and -2, 0, can we turn that into a quadratic? And the answer is no, that's not enough, because I could come up with these 2 binomials, right? But I still don't know a. And so in order to find a, I have to know not only the 2 x-intercepts, but I also need to know a third point. So let's go ahead and finish this by saying the quadratic goes through 1, 27. And now we can solve for a by simply plugging the x and the y into this equation and solving for a. So here we go. Y is 27, a is a. In place of x, we're going to put 1, and in place of x, we're going to put 1. Okay, that's easy. So 27 equals a. Negative 3 times 2 is negative 1 minus 4, negative 3 times 3. That's good math. Negative 3 times 3 is negative 9, and so a turns out to be negative 3. So the factored form of the parabola that has the two x-intercepts of 4 and negative 2 and goes through 127 is y equals negative 3, x minus 4, x plus 2. Okay, there you go. Thanks for listening. See you in class.